Welcome guys to another episode on your favorite YouTube channel, the Pathway Academy Educational Channel. Here I'll be discussing on chemistry majorly, and this is the first episode. I'm about to introduce you to JAMB chemistry. Now, I tell my students, I tell them that it is not about working hard only, it's about also studying smart. You don't just work hard, you work smart. Now, for every examination board, syllabus are given to students to master in order to know what to learn about. So you don't just learn in vagueness, you are going to learn with an understanding. So majorly what I want to work on today with you guys is introducing you to the JAMB chemistry syllabus. Now, before this class ends, I'm going to give you the syllabus online. I'll recommend you to go online and download the PDF, the soft copy of the syllabus. Now today, the whole syllabus of JAMB chemistry, for your convenience, I'm going to divide the whole syllabus into four major aspects. As you've all known that chemistry is actually the study of matter, its composition, its properties, and the relationships among matter. So that being said, the syllabus of chemistry by JAMB, given to us by JAMB, I will divide it into four major parts, and those four major branches are: number one, we have the inorganic chemistry, we have the organic chemistry, we have physical chemistry, and lastly we have qualitative analysis or practical chemistry. So we've divided the whole syllabus into four major branches. We have the inorganic chemistry, we have the organic chemistry, we have the physical chemistry, and lastly we have the qualitative analysis, which I say that it is a practical chemistry. That being said, as we continue through this episode, I'm going to give you the topics under inorganic chemistry, what you are expected to find, organic chemistry, physical chemistry, and qualitative analysis. Alright guys, welcome back to the Pathway Academic channel. Now, we've successfully established four branches of the 2026 JAMB chemistry syllabus. Now, we're going to take them one after the other. The first one is inorganic chemistry. What is inorganic chemistry? What are the topics we're expected to deal with under inorganic chemistry? First and foremost, inorganic chemistry is the study of properties, reactions, and uses of elements and their compounds. So it means we are going to deal with the properties, reactions that elements undergo and their compounds, excluding carbon compounds majorly. So in inorganic chemistry, we are going to deal with metals, non-metals, and periodic trends majorly. Quickly, let me list the topics that you are going to find out that are under inorganic chemistry. The first one I will talk about is the periodic table and periodic trends. I believe you've gotten your books and your pen and you are writing. We have the periodic table and periodic trends. Now, also we are going to have metals and their compounds. Now, the periodic table, a quick one, is the arrangement of elements in an orderly manner. Now, the periodic table is a function of the atomic number of elements. Quickly, on the periodic table, we have metals arranged. The metals we're going to talk about here are the group 1, 2, and 3 elements, which are known as the alkaline metals, the alkaline earth metals, and the aluminium family and their compounds majorly. We'll also talk about non-metals and their compounds. non-metals and their compounds. We talk about compounds of hydrogen. We talk about halogens. We talk about oxygen. We talk about sulfur and the likes. Also, under inorganic chemistry, we are still going to deal with transition metals. Transition elements are majorly metals. We are going to deal with them, their characteristics and their uses, and also their compounds. And lastly, we are going to talk about environmental chemistry. Environmental chemistry. Where we are going to talk about air and its constituents, air and its compositions, air and their compounds, liquefaction of air. We're also going to talk about air pollution, talk about water. We're going to talk about industrial chemistry also. So these are the major topics we are going to deal with under inorganic chemistry. Now we are dealing with organic chemistry. Organic chemistry. Organic chemistry is the branch of chemistry that deals with the study of carbon compounds, majorly their reactions and their uses, excluding certain compounds of carbon. Now somebody will be amazed that why are we excluding certain compounds of carbon? Now there are some certain compounds of carbon that are not organic. Now these compounds that we are going to exclude include, the first one is carbon oxides. Carbon oxide, which is carbon 2 oxide and carbon 4 oxide. Also we have carbonates. Carbonates are majorly found in carbonic acid, and carbonate ions are found inside. Example, we have Na2CO3. Na2CO3, it is sodium triisocarbonate 4. This is a compound of carbon that is not studied under organic chemistry. And lastly, we have carbon carbides. Carbon carbides are not classified under organic chemistry. Carbon carbides are binary compounds that are formed with reaction between carbon and metals or metalloids. Carbon carbides are classified based on the bond between the carbon and the metals or metalloids. We have three major types. We have carbon with metals like alkaline metals and alkaline earth metals. An example is CaC2. This is calcium carbide. Calcium carbide. So all these major examples of compounds of carbon are not studied under organic chemistry. They are studied under inorganic chemistry. Alright, the compounds of carbon that we are going to study under organic chemistry, the first ones we'll study introduction to organic chemistry. We'll be talking about homologous series, homologous series are compounds of organic chemistry that have the same functional groups. This means that they exhibit similar physical and chemical properties. We'll talk about functional groups. Functional groups are groups of atoms that are found majorly in organic compounds that give organic compounds their distinct characteristics. Also, we'll talk about isomerism. Isomerism is a phenomenon in organic chemistry when compounds have the same molecular structure but different structural formula. Same molecular formula but different structural formula. It means compounds can be arranged in different ways in their structural formula. Also, we'll talk about hydrocarbons. Hydro and carbons. It means organic compounds that contain hydrogen and carbon mainly. Under these hydrocarbons, we have three major groups. We have the alkanes, we have alkenes and we have alkynes. But also we can study benzene and its derivatives under hydrocarbons. Also we have oxygen containing compounds. Oxygen containing compounds. There are some organic compounds that contain oxygen. Examples, we have esters, we have ethers, we have carboxylic acids, we have alcohols and the likes. Also, we have organic compounds that contain nitrogen. We call them nitrogen containing compounds. Nitrogen containing compounds like amines, like amides, like proteins and the likes. They contain nitrogen. And also we can also have what we call giant molecules or binary molecules in organic compounds, or bimolecular molecules. That is, these are molecules that contain two functional groups. Examples, we have carbohydrates, we have proteins. They are studied under giant molecules or bimolecular molecules. So it means, in summary, what we are going to study under organic chemistry includes homologous series, introduction to organic chemistry, talk about homologous series, functional groups, isomerism. Will give us the properties of the different homologous series in organic compounds. Talk about hydrocarbons, alkenes, alkynes, benzenes, aromatic compounds. Then we'll talk about oxygen containing compounds also. We'll talk about esters, alcohols, carboxylic acids, and the likes. We'll talk about nitrogen containing compounds also, and giant molecules. Welcome back to the Pathway Academic channel. On our channel, we focus on making chemistry very simple for you, fun and exciting for you to understand. We'll continue on the physical chemistry. So what is physical chemistry? Physical chemistry is that branch of chemistry that is dealing with how and why chemical reactions are taking place. And also in physical chemistry, we are going to borrow from physics, that is the physical reactions, what are observable, the quantitative measurements. Also it talks about the energy that accompanies chemical reactions, change in heat, change in force. Are we together? So physical chemistry is that branch of chemistry that deals majorly with principles, it deals with theories, it deals with calculations in chemistry. So what are the topics we're expected to understand or to know under physical chemistry? The first topic we're supposed to talk about is, we'll talk about quantum chemistry. Under quantum chemistry, we'll be dealing with atoms and atomic structures. We'll discover the different stages that atom theory has gone through till the modern atomic structures or theory that we have. We're going to talk about thermochemistry or thermodynamics. This is the study of chemical reactions that involves heat changes. So this is thermo, which comes from heat, and chemistry. So it means the heat changes that follow chemical reactions. Also we have electrochemistry. Electrochemistry deals with electricity and chemical reactions together. For example, in batteries, how do chemical reactions produce electricity? Another topic we expect to understand under physical chemistry is chemical kinetics. Chemical kinetics talks about how chemical reactions takes place, the rate at which chemical reactions take place, how fast or how slow chemical reactions are occurring. Also, we'll talk about chemical equilibrium. This branch of physical chemistry is dealing with reversible and irreversible reactions, how to balance reversible and irreversible reactions. For example, is the production of ammonia, ABA process. There are some reactions that occurs in equilibrium. The reaction is going forward and also backward simultaneously. And also, we're going to talk about gas laws. Gas laws, we're going to discuss how temperature, pressure, and other factors affect gases, how gases behave under certain conditions. So these are the major parts of physical chemistry. We have the quantum chemistry, deals with atoms and their energy levels. We have thermochemistry. This deals with change in heat during chemical reactions. We have electrochemistry. We are dealing with electricity and chemical reactions together. We have chemical kinetics that talks about the rate of chemical reactions and factors that affect chemical reactions. Also chemical equilibrium. It means there are some chemical reactions that are in a state of equilibrium, that is, they are in a constant state. They occur simultaneously, the forward reaction and the backward reaction. It simply means that reactants can react together to give product, while product also are forming the reactants. Very simple. Then we also have gas laws. Gas laws talks about the factors that affect gases and how gases behave under certain conditions. All right. And the last branch of chemistry that we are going to deal with is the qualitative analysis, which I term practical chemistry. Qualitative analysis is dealing with identifying, the key word here is identifying of substances or mixtures. Now, how do you identify substances or mixtures? In qualitative analysis, we identify it by checking out the chemical reactions, observing the chemical reactions, observing the colors that is going to produce of the substance, and also observing the precipitates, and also observing the flame tests when you burn that substance in air. Now, qualitative analysis is not dealing with measurement, but what is peculiar to substances or a mixture. So in qualitative analysis, majorly we are identifying substances and their composition. And I tell students this part is also very important. If you have this part, if you know this part, you've covered like 30% of JAMB chemistry. Now, what are the topics we're expected to deal with under this? We'll deal with acid-base titrations. The qualitative parts of acid-base titrations. We'll talk about indicators, we'll talk about pH values, we'll talk about buffer solutions. Also, we'll talk about tests for cations. Examples of cations, we have K+, we have Na+, we have NH4+. So it means if I want to identify any of these cations in a substance or in a mixture, it is qualitative analysis I will use to test for it. Also, we have tests for anions. Anions like SO4 2-, sulfates, we have NO3-, nitrates. To test for these substances in a mixture, we'll use qualitative analysis. Also, we have flame tests. Also, we have tests for gases. Example, how do oxygen gas behave in certain conditions? How do nitrogen gas behave in certain conditions? How do sulfur gases behave under certain conditions? Everything is going to be tested for under qualitative analysis. So majorly, we have 4 branches of the JAMB syllabus. We have the inorganic chemistry, we have the organic chemistry, we have the physical chemistry, and we have the qualitative analysis. These are the 4 major parts we'll be dealing with our syllabus. All right, guys, we've come to the end of this session, introduction to JAMB syllabus. I've introduced you to the JAMB syllabus, and I've introduced you to the 4 major branches that we have. Do not forget there are 4 major branches. We have the inorganic chemistry, we have the organic chemistry, we have the physical chemistry, and we have the qualitative analysis, which is the practical chemistry. I believe you've understood it perfectly. Do not forget to like, share, and subscribe to our YouTube channel, The Pathway Academy. See you in the next episode.